Okay everyone, today we're going to learn about something called moment of a force. Moment of a force. And this is a very important concept for the rest of the time, so make sure that you are mastering this today as you listen. So what is the moment of a force? Well, moment is the tendency of a force to induce rotation about some point. Now, you know this. You really are good at this. You know what's going on here. Because you know that if you're trying to turn a really stubborn screw or a really stubborn lug nut or something else, it's a lot easier to do if you grip a handlebar that's very far away from that point. The reason for that is because the longer your lever arm, the more torque you have, or in this case, the higher the moment would be. So, you know about moments. You know about how it makes it easier or harder to turn something. So let's go ahead and define how we get this, because we need to have some definitions and terminology to make sure that you know exactly how to talk about this in the future. So first off, the moment arm. Well, that's the perpendicular. That's the very important word here. Perpendicular distance from the line of action of the force. That's the infinitely long line that goes straight through your force all the way to infinity in both directions, to the point about which rotation is assumed to take place. So you've got to figure out, what's the perpendicular distance to that point. And if you're not sure because it looks like it's an angle or something, well, then you just break it up into components, okay? You break it up into components and everything will just be super peachy. So from this, we get moment is equal to force times perpendicular distance. Perpendicular distance. I'm gonna circle this a couple times because this is the big one that people mistake for. It's the perpendicular distance. Okay? So you look at it right here, you see I have my line, or my lever arm, and I have my force vector, and this is the perpendicular distance. That's why it's at a right angle. It has to be a right angle. Please, 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 please don't mess it up. Right angle. Okay. Now, for a moment, units are usually Newton meters or foot pounds. There is no nice one-word unit. It's Newton meters or foot pounds. Now, you can have other things as well, but just look for what I ask in problems. Now, it is often difficult to determine the distance to the line of action, like the perpendicular distance. So that's why it's usually simpler to break the resultant force into components and use only the perpendicular component of the force in the calculation. For example, let's say that I have that lever arm from earlier. So I have, this point I'm trying to turn, I have my lever arm, but my force is just being really weird. This is my force. Well, you know what the distance is to where that force is applied, but that's obviously not the perpendicular distance. Okay. Let's see, this is theta right here. Okay. So I've got some, I would have to figure out, okay, what is kind of like that distance, d, for that force. And you can do that. You can actually figure that out. That's not terrible. Because I would just figure out, well, this is theta, okay. That's d. And so this one right here is the d perpendicular. So I would just solve. I've got my force. I have this distance d right here. And now I just need to solve for this triangle. So opposite over hypotenuse is equal to sine of theta. So d perpendicular over d is equal to sine of theta. I want to know what d perpendicular is, so that would be d perpendicular would be equal to d sine of theta. And I'm done. That would give it to me. I would have it for this particular problem based on that angle of the force. I could have also, if I wanted to, done things slightly differently and just said, okay, well, instead of looking at for the perpendicular distance, I'm going to look for the perpendicular force because they're exactly the same thing. I just need this force component. What is the force perpendicular? This is typically how I like to do it, but either way works. And so you would know that, well, that angle right there, that's going to be 90 minus theta. And, well, f perpendicular will be adjacent over hypotenuse. So f perpendicular over f would be equal to adjacent over hypotenuse, which is cosine of of 90 minus theta. Okay? And therefore, if I solve, well, f perpendicular equals f cosine of 90 minus theta. That's all based on where I put that angle theta. If it was somewhere different, you'd have to mess around with your trig functions. But you get the point. You were just looking for the perpendicular component. Okay? The perpendicular component to the lever arm. If you can figure that out, it's glorious. Now there are other instances where you would have two components. We'd have to break, do a lot more here. We'll have plenty of examples of those in the future. Now, one other thing to mention here is what is a negative moment and what is a positive moment. Okay? And follow something like the right-hand rule. How the right-hand rule works is this. This is the point that you are trying to turn it around. And what you should do is you should imagine that there is like a beam of light coming out of your computer screen, or out of the top of out of your paper. It's coming straight at your face, and you are going to wrap your right hand around that beam of light so that your thumb should be pointing at yourself. Okay, your thumb is pointing at yourself. And then look how your fingers curl. Well, they curl in a counterclockwise direction. So that is what's considered positive. A counterclockwise moment is positive. If you're really unsure about how that's working, like if the moment's going to be counterclockwise or clockwise, do this. Follow the position vector until it hits the line of action of your force vector, and then have it turn and follow the line of action. Which direction did this turn? Well, this one turned counterclockwise. In this case, I have it follow the position vector all the way to my line of action, and then it turns away to follow the force, and it turned clockwise. This one's negative, that one is positive. Okay, so we will stop there for today. Thank you for listening, and I will see you all next time. Goodbye.